presents two different approaches that we could use if we could coordinate better with existing assets and working together on collecting observations that multiple agencies need, or finding innovative ways to use more traditional techniques and observations. We can help to address our observing needs in the Arctic. So yeah, without any further ado, unless there's someone who wants to say something before the first presenter, we'll just kick it off to Lauren Decker from Polartec.
If I can unmute myself here. Okay, can everyone see my screen? We're good? Okay. Yeah, so welcome. This is Polartec's presentation on artificial intelligence to monitor coastal change in the Arctic. We are a data science and oceanography company that does for the Arctic. And I'm going to be giving a little bit of background for myself and our company and our SBIR, where we developed CENA, coastline evolution and nearshore approximation. We'll look at the study site at Homer, Alaska, and check out some of our results. I'm Lauren Decker. I am the Chief Science Officer at Polartec. I'm an oceanographer by training and have been working in the scientific consulting field for my professional career. My contact information is below my picture there, so if you need to talk to me after this, that's all there. Our company, Polartec, develops custom artificial intelligence and machine learning tools for the Arctic based on the science of oceanography. So this my little doodle over here is how we represent the Arctic as between a rock and a hard place, or between an uncharted rock and sea ice. So this is our vision of where we are coming in for our company. And so we're trying to develop tools to forecast sea ice and estimate nearshore change. Oh, one too far. So NSF funded us through a small business and innovation research grant to develop an artificial intelligence that curated an estimate for nearshore bathymetry in the Arctic. And we received this in February, and this is a phase 1 6-month grant. So it was like NSF came to us and said, hey, do you want to be like heads down and not take any vacation and not go anywhere and just work really hard for this year? And we're like, thank you. So it was the one good thing that happened in 2020. Oh, keep going too far on these things. Okay, so we prototyped CENA, coastline evolution and nearshore approximation. So this is Polartec's innovative artificial intelligence architecture to estimate nearshore bathymetry. So we're starting with some scientific building blocks for remotely sensing bathymetry. So that's waterline mapping, where you are using the bathtub method, where you take the tidal, you see where the coastline is during different parts of the tidal cycle, and then you can pin it to really tell where zero is. Satellite-derived bathymetry is pretty classically used, but it really only works in clear water. So we also looked at wave inversion, which is feeling the bottom through the modification of deep water waves coming in and becoming shallow water waves and reacting to the bottom. So taking those scientific building blocks, oh, and wave inversion also works in turbid water, which is most of the Alaskan coast. So taking those and putting them into our construction phase, the best part about it and this artificial intelligence architecture is it can take all of those different scientific methods and any other ones as we continue to find and evaluate them and integrate them into our system. And as it aggregates them, it can intelligently build new and custom models for any particular region. So regions that have a lot of turbidity or regions that are very clear, you can use these different methods in different locations, even within the same domain. So these are custom models built for particular regions. And then because it is a model itself that is developed, you can run those operationally. So in some of the locations around Alaska, they have a very high rate of change, especially along Alaska's north slope. So that helps in the sense that you can monitor the coastal change in Alaska. So here's a movie. The movie did not translate to the PDF. So if you're looking at the PDF, I'm sorry, it didn't populate right. But if you're watching live, you can see it here. So this is Sentinel-2 imagery at our test site in Homer, Alaska. It has a really wide intertidal zone, and this region of Alaska has really large tides. They are in that zone of like 15 feet differences, so like competing with Bay of Fundy over there. So we can use that wide intertidal zone to really test that waterline mapping tool. And we chose this region because it's pretty turbid, and so we could use, and it also has some really great wave fields. So we could test our wave inversion modeling in this region as well. So first, the intertidal depths where the waterline is changing. So the picture at the bottom right shows that mudflats versus ocean. And this is a Alaska shore zone imagery picture where they flew a helicopter around the edge of the coast in Alaska, and we're checking out some of these coastal zones. And so you can really see how different mudflats are from regular sandy beaches. I grew up in Anchorage, Alaska, so this is what I think of as beaches, is these very strange glacial silt areas that have a lot of very smooth, very fine silt, quicksand, basically. And it's pretty hard to tell the difference between a mudflat and a turbid ocean water. So we had to work on a classifier that could actually see the difference between what is a mudflat and what is turbidity, and drawing that line, tying it to a gauge that's in the bay, and then we were able to mark where that shoreline was. And so this is looking at 2 different years and aggregating all of those different pictures into the 2 different years of 2018 and 2019, showing some of the subtle changes. There's very little coastal erosion, but it is a pretty active area for the mudflats to be changing. So this is just looking at one of those, like the slight changes that you're going to see in the mudflat area in that intertidal zone. So taking that little coastline and going a little bit farther out to sea, same test site in Homer, Alaska. And we're using this particular image because it had a really great wave field. And we are finding the wave speed and the wave length from this image. And you use those to do a wave inversion to calculate depth. So this was the final product of water depth. You can tell it's a little choppy, but it does have a trend of deeper water out to sea moving into shore, and it gets smoother and smoother and becomes very shallow. But right at the shoreline, it is cropped, so we don't have actually like beach in this picture. So taking those 2 inputs of wave inversion and intertidal mapping into our artificial intelligence ensembler, we came up with what we think are really great water depth estimates from our model. So one of the reasons that we really liked this particular region was that it has a validation set of some high resolution DEM for that region, digital elevation model. So just to compare the 2, so this is our artificial intelligence wave inversion estimate against the survey depth. So along the 1-to-1 line means that it is estimating the same as what was surveyed. And then there's the picture again. So it works really well between the 0 and 20, but deeper than that, the waves aren't really feeling the bottom. So you don't get quite as good of a guess. You just kind of know it's deeper. So for our continuing and future work, we're looking at testing this in other locations around in the Arctic. And we are also interested in reviewing other scientific building blocks to be able to integrate into our tools. So if that's SAR, wave refraction, LiDAR imagery. So those are sort of where we're going with this right now. Where else can we apply it, and what else can we integrate into it? And this is really so that the NOAA coastal group is very interested in map once, use many times, but in Alaska, it's going to be mapped once and then track the changes in a lot of these different locations because there is such high rates of change in some of these silty mudflat areas of Alaska. Okay, I threw a lot at you. If it's all a word jumble, I will, I don't know if we're opening it up for questions or if we're going to move over to Mark. But thank you very much for attending, and please reach out if you have any questions.
Yeah, I think we could take 1 or 2 questions now because you were right on time, and we'll also have time for discussion at the end. So if anybody has any specific questions or clarifications that you want from Lauren, please ask now.
Hi, this is Bill Manley at the University of Colorado. Should I go first? So I've got 2 quick related questions. And then how did you derive elevation from the Sentinel imagery? Is that, optical? And what's the DEM resolution? And actually last, really cool what you're doing with the wave inversion.
Yeah, the wave inversion is great. So I'm trying to figure out how did I get depth from
The Sentinel imagery?
Okay, I think I have a backup slide actually that explains this, because we are literally measuring waves from space, and it's not straightforward. So I could take a long time talking about this, but basically the Sentinel imagery takes different waves or different red and blue at different times, and you can use them like a little mini movie. And so because the red and blue wavelengths are about a second apart, you can see how fast the wave moves in 1 second if you can find the waveforms.
That's really great. I was actually more curious about the earlier bathymetry map that you showed.
Oh, that's not our work. That's a DEM from NOAA.
Oh, right. Gotcha.
That was one of the reasons we chose this study site, was because that there had been a recent survey that NOAA took. And actually that ties in very well with Mark's presentation, is we have to tie this in with on the ground measurements to make sure that we can train our artificial intelligence engine on what it's seeing. So it doesn't have to be a lot to be able to train on, but we do need those on the ground measurements.
And then you could extend it to other areas. This is really interesting. Thanks.
Yeah.
So that's a perfect segue. Thank you.
Right?
And
Perfect segue.
We'll open it up to discussion, and you can ask Lauren more questions at the end. So next presenter is Mark Stoddard. And I'm sorry, I'm going to botch his biography, but anyways, he's in a research group up in Canada, and he worked with the Canadian military, and he's going to tell you all about that. So why don't I just let him talk. Thank you.
Yeah, thank you, Jonathan. So, my name is Mark Stoddard. I'm a defense scientist at Defense Research and Development Canada. I'm sure a lot of you don't know who or what that is, but we're a federally funded agency within the Canadian Department of National Defense. We operate 8 labs across the country that all have a specialized area of research of military relevance. My lab's the Atlantic Research Center. So we do a lot of, traditionally it was underwater warfare, work for the Navy, sonar, acoustics, but more recently it's branched out into a broad spectrum of sensors, systems, platforms, and environmental characterization efforts for all maritime regions, including the Arctic. For those of you that don't know, DRDC in general has been conducting research in the Arctic continuously since about the 1950s. We've had permanent research camps in Cambridge Bay. We've had them up on on Devon Island. We have one currently there that's been permanently operated for the last 40 years on about 74 degrees north. And then we have a footprint at CFS Alert, which is about 86 degrees north. We visit these places usually all summer. We don't usually go up too much in the winter. Of course, it's hard to get there, hard to operate there, not much going on other than environmental observations. So those are kind of unmanned systems now. But essentially that's what we do. And my group's operational analysis and systems integration. So I deal daily in data collection, how we then exploit that data to support decision-making for the military. So today I'm going to just highlight a couple activities if my slides will ever advance here. They're not moving, they're frozen. One sec. I don't know why that's not. I'm locked out. One sec.
Did you need me to do something?
I don't know. For some reason, my slides won't advance. So one sec. I'm gonna have to try resharing again.
That doesn't work, Mark. I have the PDF and I could share from that.
Yeah, we might. I don't know if it's because I'm using Office 365 and it locked me out, but I just need 2 minutes.
Yeah, well, we can use that 2 minutes as
Please, yeah.
as a question for Lauren.
Yeah, this is Mike. I'm a co-data team co-lead. Quick question about site selection decisions. So how representative is the site that you're showing in terms of being able to map coastlines in other parts of Alaska? And do you consider the needs, the information needs from some of the stakeholders there, including local communities, in doing site selection, or is it purely to answer the geophysical science questions?
So when we started out this project, we were really interested in coastal erosions because of the communities out there having a lot of their houses fall into the ocean. So this is, you know, Shishmaref. This is a whole lot of different locations around Alaska that are having coastal erosion problems. So that's what was one of the initial inspirations. I think Leslie is also on this call, so I might have her help me out here. The turbidity is very representative. The mudflats are very representative of a lot of Alaska's coastline. I think many people might be a little bit more aware of some of the southeastern, the panhandle of Alaska, which can be hard bottom, a lot clearer, a lot more fjords. But most of Alaska is pretty turbid, pretty mudflats, and this is pretty representative of that. There's so little data that we couldn't extend this to very many different sites around Alaska because we couldn't validate it. So that's currently our big issue, is trying to find the right kinds of data sets to be able to do in these really turbid regions, validation of depths.
Thank you. Yeah, it would be really interesting to see even just the decisions behind the site selection. Obviously, you'll include that in the methods, but raising awareness of the constraints, data availability. Clearly, survey data are, there's not full coverage in all locations where you need it, so that's obviously a consideration. But then also the other aspect, enhancing likelihood that the models you're creating, the information, the data you're creating can be used for other purposes, not feeding the science answers, but also maybe just addressing information needs and reasons why or why not that was considered in the site selections as well.
Yeah, and that's certainly one of the things to think about when looking at thinking about sea level rise and how you can monitor it using some of these remote sensing methods and hunting down where the coastline is before and after or during a flood. So there's a lot of coverage from Sentinel-2 up here. The biggest challenge with Sentinel-2 is that it doesn't see through clouds.
Thank you so much. So I obviously dock me for the discussion. That was some of the questions I had. Mark, are you good to go?
Yeah, I think so. Yeah, it's moving.
Okay.
I'm assuming you can see the slide now. So
We can see stuff.
Yes.
perfect. Okay, great. I don't know. I think I got logged out of my email at work. So anyways, back. Yeah, so I'm going to talk just about 3 activities that are kind of data focused. I would say a lot of them are collaborative with US NRL and Naval Research Laboratory and other government departments in Canada. But just to kind of give you a feel for data collection efforts that we have underway and how we perceive those kind of moving into the future. So the first one is looking at getting a better understanding of the contribution that surface ships can make to maritime domain awareness in the Arctic. You know, there's not a lot of traffic up there. There's not a lot of ships operating year round. So it's sort of viewed that their contribution is minimal. And what we're just trying to understand is through collaboration is if we expand our efforts to promote enhanced data collection from surface ships operating in the Arctic, what would be the operational benefits of that? Both for just pure domain awareness of what's going on, but then the other is more for improving navigational risk management. The Navy and the Coast Guard are spending a lot more time operating in the Arctic, so are new ship operators. So we want to ensure that they can operate safely, focusing mostly on navigational safety. There's obviously other risks from spill and environmental response, disruptions to local communities, all these other aspects where I'm focused purely on navigational risks to ships. So part of the objectives we're looking at are just developing robust unattended Arctic data collection and reporting systems. So trying to understand what sensors, how do we want to integrate them, and then how are we going to communicate that data back down south, at what bandwidths and at what rates. The others starting to get a better feel for the metrics for how we're going to measure the contribution of surface ship observations to MDA. You know, that whole value of information. We're collecting data. How do we understand its value so that we can start to make kind of economic decisions on how much to invest in onboard ship collection capability, how much communications bandwidth do we give to real-time measurements and getting those back down south, those sorts of questions. And then the last is trying to understand the role of these surface ship observations in risk management, navigational risk management. So if we do a better job of characterizing the ice using local ship observations of ice regime, how will that improve risk management, like navigational risk management? The way we're going to be doing that is mostly using commercial risk assessment systems like Polaris. I don't know if you guys track the Polar Code or any of these ice limitation risk indexing systems. There's many out there now. Polaris is one of the mainstream ones, which tries to take into account a ship's design capability and the ice regime and various risk indexes to produce an outcome. That outcome is everything from ops not permitted to unrestricted, and it varies based on the ice conditions. One neat thing is that system was developed to be kind of conducted by an ice navigator on board a ship in an ice regime that he's personally observing. But because remote sensing is becoming so much more widely accessible, that they're starting to look at the use of these systems over wider areas for more operational planning of routing. So if you want to go from Nook to Resolute Bay, you know, you can sort of visualize the ice conditions along your entire route now and perform a risk calculation of where do you expect to get in trouble, where do you expect to be kind of low risk, high risk, and then all of that kind of equates into the impact on transit time. Those are kind of where we're focused. And yeah, so we're continuing to move on. It's going to be a 3-year collaboration going to 2023. And it's still just kind of getting started due to COVID. The next is a very recent activity. So I don't know how closely everyone's tracking shipbuilding in Canada. We don't do a lot of it, but we are building 6 new Polar class ships. So these are going to be PC5 vessels. So they'll be allowed to operate year round in the Arctic. Part of that process is doing contractual acceptance of ice breaking. So they have to demonstrate that they're meeting the design limit. So part of that is the Navy has to take them and operate them in 1 meter ice. So again, with support from various partners, both in the US and throughout Canada, we've been providing the ship with daily, if not 3 times daily, ice trial. We're calling them ice trial requirement assessments. So we're not presenting them ice charts with egg scores. We're presenting them a decision criteria, or the outcome of a decision criteria that's trying to look at, will these ice conditions meet your trial requirement? Again, the command team on board these ships aren't seasoned ice navigators. They're commanding officers that have done most of their training far south of the Arctic. So presenting them ice information in a format that can be easily consumed and make decisions made upon was a big push for them. And that's kind of where we've been focused. So the top product there is kind of a daily product using the Canadian Ice Service daily sea ice charts converted to this decision product. And then the model below is using ice forecasting information from the Global Ocean Forecast System, GOFS, from NREL. Again, presenting it not as ice thickness, but as, will this ice thickness meet your trial requirement? And then that's sort of how they decided on where to go and when to test. And that actually successfully completed a week ago. So the quality of these forecasts and ice products was enough for them to find the right ice. Lastly, this is another more recent effort. I'm sure all of us are trying to engage better with industry, who are the ones operating the most in the Arctic, at least in Canada, especially in the Eastern Arctic. So we've been reaching out to FedNav, who have year-round operations up along the coast of Baffin Island and into the Davis Strait, trying to convince them that it'd be great if they could share bridge observations with us on a routine basis. And they've been very compliant. Whenever we ask, their commanding officer will send hourly reports of ice regime, including these pictures from their bridge cameras. And they did that every hour when we asked for it during this trial period that we were examining. They even took the time to standardize the recording using Assist, which is a sea-based standardized ice reporting tool. And have even entertained the idea of carrying unattended observation and reporting systems, where I talked about in the first slide, we were focusing on putting
Uh-oh, did we, is Mark frozen or?
I don't hear him either.
systems to underwater acoustics. So this is just focusing on maritime domain awareness activities, but I'd be happy to.
Oh, Mark, we lost you for a minute there. So if you could just re-say whatever you said in the last like 30 seconds, that would be great.
Yeah, I was just trying to say that this is only a small sample of what DRDC is working on in the Arctic. And again, more heavily focused on maritime domain awareness, but we have lots of researchers looking at power and energy systems, environmental characterization, remote sensing. And I'd be happy to, again, provide that material to those in this working group, or to connect anybody who knows of DRDC and has an interest in learning more or connecting with a specific researcher. I'd be happy to do what I can to make those connections as well. And for Rick Allard, if he's on the phone, he asked me to produce a polar bear photo, and I did. So, and we spent $150,000 on a bear fence that is tipped over and standing, and they don't work. So just so you know.
Great.
Thanks.
Thank you very much. That was a good pair of presentations, and we left plenty of time at the end where we want people who called in questions. We can open it up specifically for questions for the first few minutes for Mark's presentation, and then we can have a more general discussion. Just to start, are there any clarifying questions for Mark?
I have a question.
Okay.
I have a question to Mark.
Yep.
I'm working on remote acoustic sensing of ice, especially ice type, like first year versus multi-year ice. Do you have any activity in that regard?
Well, we do a lot. I mean, are you talking from like an ambient noise perspective, like the sound of ice cracking through different ice types, or?
Well, it's I'm talking about active sensing. So it's
Oh,
so you have ULS, for instance, or
We do-
satellite, any kind of acoustic sensing.
yep, we do a little bit of that. We don't do a lot of active in the Arctic just because it's so hard to get the permits to transmit for us. We still do mostly passive acoustics in the north, but
Mhm.
we have an interest. Obviously, we do some higher frequency stuff for ice keel avoidance for submarines and those sorts of things up around 40 kilohertz, but not much other than that.
But at least you have, I guess, as a result of what you're doing, you must have kind of database of ice properties, right? Which can be used anywhere.
Yep, but not, yeah, we do for low frequency for modeling propagation under ice, but not a lot for, like, no one's looking at you, well, no one I'm aware of is looking at characterizing the ice type based on the acoustics, active acoustics. But
Okay, thanks. Anyway, so I think it's an interesting topic to discuss, but maybe it's too much details. I would be happy to discuss and kind of afterwards.
sure.
So this
Thank
is Mike Brady. Quick question for Mark.
Hmm.
Looking, what's in your opinion, the value of looking at past data? So in particular, ship tracking data. Do you see value in looking back at vessel patterns and kind of how that matched against some of these climate conditions? Thinking about things like emissions. Are there ways to kind of reroute traffic patterns? Obviously, considering sea ice and other variables you got to watch out for. But looking like, so it sounds like you're looking at current data, predictive analytics. But what about insights from looking at past patterns?
Yeah, we're not really doing a lot of that currently. Like I have an interest in looking at like very high resolution observations of how ships are operating in ice to try and get a feel for what the ice conditions are like based on observing a ship. So you're tracking a ship in the Arctic and all of a sudden it's slowing down to 6 knots. Well, if you know the design of that ship and its ice capabilities, can you use that observation of a ship's kinematic behavior to kind of sense the ice condition? That's the only thing that we're kind of looking at using ship tracking data in the north right now. But obviously, we definitely look at developing traditional like routes, like looking at historical shipping activity in the north to understand where the corridors are, and that's where we focus our sort of not surveillance effort, but we want to focus like better mapping in areas where we know ships are going and those sorts of things, or mitigations we would do in those areas. But I don't know if that answered your question.
Yeah, no, thanks, Mark, for, yeah, I'm always curious about how, historical data like that can be used to inform some science and decision making. I know that some of these questions are really, they're being answered with like current data, given the current environment, and then also predicting. But obviously, there's some value in looking at past patterns as well. And I was just wondering if you guys were doing that at all. And it sounds like not so much, but that are using historical AIS in some cases. So it'd be interesting to learn more about that.
Yeah, like the most we're doing is just characterizing speeds and understanding when a ship's speed is an unusual speed based on like, is it driving too fast for the ice condition or too slow? So we've looked at kind of histograms of speeds in the various parts of the Arctic, and when is somebody significantly exceeding the speeds we expect to see at that time of year. That's kind of the only learning we're doing on old ship tracking data.
All right. Thanks, Mark.
So yeah, to try to motivate the broader discussion that we have reserved for the end of the meeting, we'll bring in our topic, our reoccurring topic that Mike Brady and I are interested in. And the reason we organized this particular meeting is in the IARPIC space, you have these, you have a lot of different kinds of research occurring. And we wanted to specifically focus on practitioner engagement and co-production models because we feel like if we could get more coordinated with the decision makers and their information needs, the data, the information that are produced from this research will be much more effective and cost effective and support those decisions a lot better. So this is just two examples of really really great research that can be applied in that decision-making practitioner space. Does anybody have any thoughts that just riffing off that theme, or Mike, maybe you could speak to that more?
I'll just open up with a general, like a pointed question for both speakers, perhaps for discussion. So I wonder about what some of the lines of communication you have with others working, you know, in a somewhat separate sphere, like scientists versus practitioner spaces. Obviously, the SciArctic Forum is a good way to do kind of a mashup, bring these communities together. But in general, like, so Mark, what are opportunities you have to talk to scientists about their observing needs, and potentially identify some in situ observations that you may be collecting for your more decision support related observing needs, like that discoverability of the work being done. And same question over to the Polartec group. What's the, you know, what are the opportunities for communicating with some of the decision makers, land use managers that would be interested in not only the findings of your science, but also the information and data products created in the process?
Yeah.
How do we communicate? Yep. Go ahead,
Yeah, I
Mark.
was going to say for us, I mean, again, in defense, sometimes it's always hard to figure out how we work with the universities, but I guess we have commitments in Canada to open data like everybody does, but I'd say we're far behind where the US and other folks are. But for the Arctic, the data we collect, for the most part, I agree, is largely undiscoverable outside of the Department of National Defense. And I think there's commitments to try and improve that. Again, like RadarSat Constellation mission, for those of you who follow space-based synthetic aperture radar, I mean, that data is being made freely available to Canadian industry, Canadian academics. I mean, that's a huge commitment on Canada's behalf to improve remote sensing in the Arctic, or globally, but primarily in the Canadian Arctic. And I think that's where we've put a lot of our effort in, is making remote sensing data more available. The notion of sharing kind of these difficult to make observations from ships or from remote sites in the Arctic, I think that's where we struggle the most. And I agree that that's tough, because it's a lot of effort to put things in a format that you can easily share and give to people without being kind of putting in a ton of work yourself to make it shareable. But that's all I'll say to that.
Yeah, I might actually build on that, and that the government has it really tough in that they have to make it set it up so that everybody benefits. And as a business, Polartec is really trying to fill in that gap from where is the government able to support as many people as possible, and then what are the individual needs, and we're trying to fill in that gap. I see Leslie is on the call, and she might want to talk more about that. I don't know, do you want to say anything about, I don't know, we're in the Arctic Economic Council as one of the efforts to try and communicate the science to the people who actually need it to make decisions out on the water.
Yeah, and from a community perspective too. So we're an Alaska Native business too. So we're also interested in those community needs, and then also the business needs, and tailoring it to what people are interested in. And so like it's kind of interesting that we actually have done most of our work in Canada, and like working with FedNav as well. And then now we're currently working in Hudson Bay. And so it's just one of those, like, I think there's something Lauren kind of touched on, but didn't really hit too much in her presentation. And that's that the tools that we're making can be applied anywhere. And the joke that we like to say is that we choose the hardest places to work. And so when you're working in this data desert of like the Arctic, where you don't have some of this ground truthing information or some of those data needs, how do you get really creative about using what you have? And then like the example of using the Sentinel data and the different wavelengths captured at different times to get the wave velocities for the wave inversion is just like really getting as much information and data out of the different products as we can. So
yeah, You remind me of one further push we have in Canada now is to establish what we're calling sandboxes, where we pick areas where we do focus data collection on for the development of machine learning AI type data intensive research that needs every type of observation possible. So what we'll do is pick geographic regions which we know are interesting, focus a bunch of data collection and make that data available for companies. So that's kind of one effort that's kind of catching a little bit of momentum, is that you tell us what type of data you're looking for, and then we focus an effort for everybody to kind of say, okay, well, we'll take this, you know, area and map it with high resolution multi-beam sonar, and let's put out acoustic recording devices, like every type of measurement we can, and then that's a curated data set that's available for validation.
I see that we have a hand raised. Randall Key, would you like to say something?
Well, thank you. My call sign Church, so most folks know me by that. I'm sorry for not putting that in the name block. I just want to say, first of all, compliment the presentations, and Mr. Stoddard, thank you for those reflections. They're just simply outstanding. I have the privilege, along with Doug Causey on the call here, of leading the Arctic Domain Awareness Center at the University of Alaska, that is really trying to get at this business of bringing science and operator communities together, focus on the U.S. Coast Guard's mission set by really using U.S. Coast Guard to help inform the community science as much as getting community science to inform the U.S. Coast Guard. And there's an additional part to this, though, as far as this kind of collaboration, and this is regarding the International Cooperative Engagement Program for Polar Research, ICE paper. On the call, John Woods serves as the overall EXO executive officer to the chief of naval research on this activity, but it is a multinational research collaboration. Again, science and operators and operational science within the Ministry of Defense and security sectors. And so it's we in Adac, though, have the ability to have the privilege of leading what's called the Situational Awareness Working Group for the U.S. in this ICE paper collaboration, which leverages what we do in Adac through this multinational security and defense forum. My co-boss in this activity is the Situational Awareness Working Group lead in Denmark. So we're trying to feed this multinational group what we're doing in the U.S. side on advancing domain awareness technologies in the community of science, again, to the operator community that is involved in defense support of civil authorities and more, trying to fill gaps in knowledge, gaps in science and technology, and in ways that advance domain awareness from an operator standpoint. We're looking at things such as position, navigation, and timing, sensors, communications, connectivity, and more in the SOG. And then, of course, this is similar to what we do in Adac. So what I would offer to you all, that this forum here, and not to get too deep in the weeds on this, just put a cameo out there that we'd be happy to follow up, because in a subsequent conversation, because in case of Canada, DRDC has a tremendous advocate in Mr. Von Cosman there that is working this, and we work in Adac with Dr. Paul Hubbard in DRDC as well. So there's a lot. Again, this Venn diagram of activities of where people are working is really remarkable. And I would just like to put down as a comment to this that there's project work that we can talk about that fits in the SOG. There is about the business of decision support for vessel operators with ice conditions. The briefing that Mr. Stoddard was just giving a moment ago, this fits right into an Arctic ice condition index decision support capability we're developing for the U.S. Coast Guard in the Arctic region and more. So I'll call that a cameo, but I just want to know, I don't want to compliment the presentations, compliment the good conversation, and offer a willingness to offer more. I'm sorry for being late getting here, just too many meetings, but that's life in Zoom land. I just thank you for the opportunity to present those thoughts.
And this is Doug Causey. I'll add just briefly. I put the website address for Adac in chat, and if you go there, you can find a lot more about the details about what Church just mentioned, and you'll see that we collaborate a lot with many of the agencies and countries that have been mentioned so far. So please look at the website, and we're a university-based center and we're here to help. Thank you.
Great. Yeah, this is great. And I think you're making us look good that these two presenters, there's a really nice meshing here that we couldn't have known starting out and planning this meeting.
This is Mike. Something that's really difficult to do is get concrete impacts out of these meetings. And I don't want to force the issue, but I wonder if there are ideas about, hearing some of the work that Mark's doing, if there are like concrete examples of potential like in situ observations that can be used to support some of the erosion monitoring work. And something that would be terrific. It'd be one thing if you guys can link and figure out how to share resources like that, but let's hear about it. Like this would be a really meaningful best practice to come back, and as Church was saying, like follow up and let's kind of analyze like the significance of such a collaboration and a best practice that others can potentially learn from. So just without forcing the issue, like I really, if there are connections that are made like that, please approach us at ARPIC and offer to share. We'd love to hear about it and discuss this further.
Yeah, I agree, Mike. It may not be me. We have a remote sensing group that would probably be very interested in your coastline. Coastline erosion is obviously a big deal in the Arctic, and the navigational hazards that pose for people that use the shoreline to navigate a bit. So I can find out who's actually doing that. And I know in Canada, it'd be a heavy focused on RadarSat constellation mission data. So since that's our data in general, and they may have data sets that are releasable already, specifically for those sorts of engagement. So
that's terrific. Yeah, and to your point, Mark, this is a lot of work to make those connections, especially when you're hampered by doing the work that you're charged to do. Taking the extra step to reach out to others that may have other questions that they're trying to answer is not always rational. So maybe just doing it proactively and just to show how it can be done, the challenges, and maybe gleaning some of the benefits that come out of such collaborations. And we do have Olivia Lee on the line. So one paper I really liked that she led, I think it was designing SAON systems, was the importance of being able to influence these observing systems, kind of not necessarily when they're designed and you have your mission, you've got to answer some questions, but in the process of starting to organize and orchestrate those observing systems, there are opportunities to connect with others that may use them as well, which could influence the work that you actually do and potentially increases the likelihood it'd be useful for other purposes. So little plug of Olivia Lee's work. I don't know, put her on the spot there, but love to hear her thoughts on this as well.
Thanks, Mike. I appreciate what this collaboration team is doing and bringing all these efforts together. I think it's very easy to get siloed, and even at a national level. So having even any kind of information from across the border is really, really helpful, because all of these efforts are ongoing, and any opportunities to find synergies, they are few and hard to come by sometimes if you're not in the group. So I appreciate what this collaboration team's doing.
Thank you, Olivia.
And I would actually like to plug that there's a lot of Indigenous knowledge that's really helpful in some of these cases. We've been looking at depths in, this location in the Hudson Bay, and one of the partners that we're working with has come up with these SAR images that show some of the polynyas, and going back into some of the interviews that have been done in that area, those polynyas were known and actually named already. And so it's really fun to be able to go and see those things. And as we're looking at it from a depth perspective, we're wondering if, some of those polynyas are actually related to subsurface seamounts. And if you're interested in traveling the easiest route in a ship, you're going to be looking for those open spots. And if you're finding those open spots and not realizing that there's a subsurface mount there, that's an extra hazard. And so being able to connect subsurface and nearshore depths that would be a hazard to sea ice, and being able to find safe routes to be able to travel, I think would be a really interesting method. And when it's a polynya is particularly reoccurring, then you're really going to be interested in, is it an upwelling event because of a subsurface mount, or is it, tidally driven, and there's really just a spiral of, water that's coming up because of the particular circulation in that area.
So this is an awesome point. This is something that the local knowledge, at least on the North Slope, that I had a little experience with talking to some of the locals there. It's something that they really are very familiar with. Where are the persistent kind of exit routes should a storm come versus those that are kind of moving rapidly? And that surely, if some of them, they've been there for decades. Some of the locals their entire lives, they rely on particular cuts in the barrier islands. That's something, we can map that and, use that as like, this is reliable in terms of, a safe refuge for small boats, but also, identify those that are moving more rapidly and focus your attention on some of the dynamics there versus those that are not changing as much. But then the question there is, the structure is how do you effectively include some of that local knowledge? It's just so hard to do. It does take a lot of effort, and I suspect that doing it, there's so much benefit there. We just need to go do a little extra work to tap into that resource to show it as a best practice to really understand the value, appreciate the value.
We also have to be aware that if we're going to benefit from that traditional knowledge, we need to do it in a sustainable way so that we're giving some of our, satellite analyses and data that were informed by that back to those communities, and showing that connection between what Lauren was saying. Well, the reason why this Pollyanna is here is because there's a seamount. That might not be something they've connected, and building their traditional knowledge is an important contribution we can make for them. That was a good example. So we are coming up at the top of the hour. I appreciate everybody calling in today, and I just know that everybody's busy, and this is the third Zoom call for you. So I'm okay with cutting off a little early, unless someone has a burning question.
I have this is Florence Federer with National Snow and Ice Data Center, and I have a real quick question. Speaker mentioned the assist observations that FedNav was taking, which is great. I'm so excited about that. I just want to make sure that they're getting into one of the archives for the assist data. And the two I know about are Pangaea, and there's a Norwegian site, I don't remember, that is also archiving the assist observations. Do you know about that?
Yeah, they haven't been uploaded yet. So right now they're just sitting in the computer that they're using, stored locally on their hard drive. But at some point we will try and upload them to, I think there's a process to do that. So we used it just to kind of standardize the recording and the databasing of the observations. But obviously we know that system was primarily developed in order to feed those into this two larger national systems in a formatted message kind of structure.
Yeah, thank you. It's widely useful data, so thanks for that.
Yeah, the intents they will go there.
Right. Yeah, we have to be checking our archiving boxes. We're very interested in those more traditional data topics as well on this team. So thanks for bringing that up. Well, anyways, I think I'm going to call it for today. Thank you, everybody, and have a nice rest of the week.
Thank you, Hazel, for holding us together here. Thanks, speakers.
Yeah, thanks, everyone.
Thanks, Lauren.
We'll share the notes and the recording on the IRBIC website shortly.
Right.
But